Hi friends, it's Kamal and you're watching Maths by Jajuria. Please don't forget to subscribe my channel. In this video, I will explain exponentials and logarithms. Main topic here is logarithm. However, before we discuss logarithm, we need to have a bit more knowledge on exponentials. So let's start with that. Function of a form. So if you have any function fx equal to the a to the power x, where a is constant. So in here a is constant, called exponential function. You see, in your previous videos we discuss like where you have x square or y to the power 3 like this. This is more like you studied in GCSEs in your 9th, 10th grades. Here is slightly different. You have x here variable and then the power was given to you. Okay. However, here in exponential functions, we will discuss function where you have a constant. So this is the example where a constant, let's say it's 2 here, which is constant, to the power x. So we will discuss this kind of function. Now, let's talk about table. So look at the table here, table of the value. So in here, you have y equal to 2 to the power x. Now, as you insert x minus value, minus 3, minus 2, minus 1, you see you get here y less than 1, so quite a low value here. So in here is 1 over 8, 1/4 or half. So the graph here will go very close to the x-axis, however in negative side. Okay, so these are their behavior. You will see when you have a constant, how the graph will draw, how will you sketch the graph. Okay, so this is what the shape will get. Soon you get 0, you will have value here as a 1, because as you know, anything a is a constant, so any power to that 0 is 1. Okay, so this is what we studied already. Now I would also suggest that if you're not sure about these, which we have already done in my previous videos, I will have the link as well in the description box so that you can go through that and just revise on that one before moving to that. Now, with some example also, we will sketch the graph and discuss how the graph will look like, the nature of the graph with the exponential function. So in here, what has been given? You have been given y equal to 3 to the power x, y equal to 2 to the power x, and y equal to 1.5 to the power x. Okay. Obviously, I'm not going to go into the table, what was the value. Okay. However, just go through what the graph would be and discuss that on that. And then later on, we will also compare exponential function and logarithm function as well. So that will give you like a clear idea on that one. Okay. So let's see here what you have got in here. Okay. So this graph here, which is just any value you getting here 1. So all the graph you see here 1.5, whether it's a 1.5 to the power x or 2 to the power x or 3 to the power x, they all value goes through when you have here 0, and that will give you 1. Okay, so you see all the graphs is passing through 1 here. Okay, where the y is your 1, right? The reason for that is because your a to the power 0 is 1. Okay, so that's why all the graph you see pass through this point. Okay, now in here you also see when you have your x greater than 0. Okay, when you have x greater than 0, you will get 3 to the power x is greater than 2 to the power x greater than 1.5 x. So that's what we're talking about here. Greater than means here that the value you will have like this. So the 3 to the power, whenever you have the x greater than 0, so which value would be higher? Like we've seen here, when you have value greater than 0, which is like 1, 2, 3, x 1 more than 1, 2, 3, you see the y you here is on 0 is 1, when you have x is 1 is 2, and when x is 2 is 4, and when x is 3 is 8. So you see how the graph goes. So exponentially it really goes high dramatically, yeah, rather than going this way or lower and then going up. With the value it really sharply increases when you have anything more than x is greater than 0. Okay, so that's what it's trying to say to you here, the sudden change in your graph. Okay, and that reflects you here, these one here. You see your highest value, the graph goes like this here. With anything after 1, you see from this point you have y equal to 3 to the power x sharply increased. Then you got y equal to 2 to the power x somewhere here, and then 1.5 is somewhere here. Okay, however, if you have x which is less than 0, okay, so you can say in minus, like here, your value y value really gets smaller value, is kind of diminish, where is going very close to x. So you see here, this value here, which was higher when x was greater, you will see here this will be kind of the lowest one. Okay, so it will now flip. So in this way, what will happen? In this way, it will less than. So now the value of the y reverses. Like here, it is very close to your x-axis. Less value of your y than the next one, and then the next. So like here, when the x was greater than 0, what you got here, that will just reverse it, which means all the value which we had up here now is other way around. So the graph will go this way. Okay, so value is really low compared to when the x is greater than 0. So that's why you get the graph here going very close to like 0 on x-axis. Same thing here as well. Okay, so these are the 3 graphs which I discuss here, so that you understand how the exponential function really behaves. Okay, before I move on to logarithm and then also discuss their function. Okay, so now I'm gonna move on to a logarithm. But before I move on to the logarithm, I will explain to you a bit about the relationship between exponential function and logarithm function. So the logarithm function are inverse of each other. So like exponential function and logarithm function are inverse of each other. So when I'm talking about logarithm function, is inverse of exponential function. Okay, what exactly that means? You see, in exponential function, you have a value form. This form you have a to the power x, where a is constant. So this is what we already have discussed here, up here. Okay, where is a function of the fx? Okay, equal to the a to the power x, and where a is constant. Now, in logarithm function, on the other hand, is asked to what power must we raise a base b to get the given number. So this is what we're going to discuss now. This is what I have to explain to you. Okay, so just bear with me, please, before we move on to that one. Right. Okay. So with the exponential function is a function where independent variable, often x, appears as exponent. So let's just comparison. So here the x appears as exponent. So we call this exponent as well. Okay. So when we compare this, I can write down here for you. So this is somewhere here. We write down, let's say, these you need to know because when we solve the problems, the understanding of these two is very important. And you got here logarithm function. Okay. So with here, in here, exponential function, we say we have an independent variable. Yeah, often x. Okay, like x. Okay, so let's say that's the example. Appears as an exponent. So this, what we call this x here, we call this exponent. Okay, and whereas in your previous videos we discussed this as like a power and things like that. So you can say anything. You can say power, exponents. So that's not a problem. Okay, sometimes we used to call that index as well. Okay, so that's not a problem. You can just, but in here we say exponent, depending on what we are discussing. In other hand, logarithm function is inverse of an exponential function. So when we talk about logarithm function here, then we say the logarithm function is the inverse of an exponential function. Okay, so this is just the inverse of that. Okay, so that's the one comparison. What's the second one would be? The general form here with the exponential function is fx equal to ax. This is what we already have discussed, where a is a positive constant and a is not equal to 1. So this is like a condition they have here, that a here must be positive, because if you have a minus, then the whole value changes. And then you can see that if you give a minus, then try to put x value in there and then see what you get. Okay, and you'll be surprised to see what kind of graph you will get. So this is here a, and that's positive, and a is is not equal to 1. Okay, so remember that please here. And where in logarithm we will have a general form like say okay, something like this, where b is base. Okay, so the b here is base, a positive constant not equal to 1. Okay, so here we will, when we write down this, like log is like a logarithm, okay, short of logarithm, that's why we just say log. And then we say b, so b will be the base. Okay, so remember that please. Base, a positive constant but not equal to 1. Okay, so that will be, again, that will be the positive constant. Okay, but not equal to, so base is not equal to 1. Okay, and your x here, okay, that is your argument. So that you will, like, depending on what the argument is, that is your x. Okay, so x would be always argument, like your variable, so depending on what we ask. Then you have exponential functions examples like 2 to the power x, 10 to the power x, and you also have e to the power x, where we'll discuss that as well, where e is like I write down for you, where e is Euler's number, okay, which is approximately, so that is approximately 2.718. okay, that is your e here. Okay, the reason they call this Euler's number, because this number was given to us by Euler's, one of the scientists, so that's why they say Euler's number, and the value for that e is 2.7118. so for time being, just remember that please. In the future videos we will discuss in details. Now we have in logarithm function here undoing, in other words, that exponential function logarithm answer the question what power. So in here, compared to what here, in your logarithm function we say what, so this is what we will discuss, what power do we need to raise, yeah, need to what power do we need to raise the base b, yeah, to get to x. Okay, so that's like a question. So what power to the base? Okay, so what power do we need to raise to the base to get the x? Okay, because x is in the argument here. So what power you give to the b, and this is what we will discuss. Okay, so just bear with me, and we'll discuss that. Now with the exponential function, you will see the rate of increase in proportion to the, so that you will see the rapid growth in exponential function, like we done this one here. You see here in exponential function you had a rapid growth. Soon the any value was greater than 0, the value really increased. So there was rapid growth. So this kind of growth you called. So you can say exponential function exhibit rapid growth. Okay, so I can write down this one here. So the exponential function exhibit rapid growth. Okay, got that? where the rate of increase is proportional to the current value. Okay, so you can say that as well, where the rate of the increase is proportional to the current value. So depending on the value. Okay, now in here the growth logarithm function is much slower than the exponential function. Okay, especially when base is small. So you will see if the base is small, like if the base is 2, then you will see the exponential growth is slower compared to the logarithm. So we can say here that the logarithm growth, okay, so logarithm growth is logarithmic growth is much slower than, okay, so your exponential growth. Okay, especially is saying that also that especially your base is small. So if the base is small, it will have a slower growth, and this is what we will see when we go through some of the examples. And then the relationship. Okay, so that's a very important part here. What is the relationship? Okay, so relationship between these two. Okay, so here what is the relationship? So this is for both of that exponential function and the logarithm function as well. So that in the relationship, if a is to the power x is equal to y, okay, this is we're talking about here. Yeah, then I write then in the middle. Then you got how we will say, because it's the inverse of that one, then we say logarithm of a. So we say logarithm of a, okay, to the power y here is equal to x. Okay, so this is how the relationship is, we will write. Okay, so so let's go back again here. Here a is the constant, x is in the argument, and that's why y is your function. So if the y is equal to a to the power x, that here the relationship would be with the logarithm. So what we do, the logarithm a here, which is constant, and this is the a, we will saying get logarithm of a, which is the value of y here, we get with the x here. Okay, so the argument here, what will be the x here? X for here, the value for relationship of your exponential. Okay, here what we say here, constant to the power x, but here your argument goes this side, and then we got the logarithm of your base. So that's why you go back again here. What we say here, we say the power, what we do, the power, what power do we need to raise the base to get the x? Okay, what power we need to get to the base in order to get x? Okay, so let's not go into too much on the comparison. Okay, let's come to the real problems now. Okay, and just solve the problems. All right, one thing here, just to start the logarithm, the expression we need to write. So first we need to learn that how we write the expression as a logarithm. So before we do anything with this, let me just write one. If you have, which is already have explained to you here, if you write the expression here, logarithm a here with the n, okay, that means here a to the power x, that is equal to n. Same thing what we discussed here, okay, where a is called the base. So then a is called the base, where a is called the base of the logarithm. Okay, so remember that, please. Same thing here. So you can say the a here is the base. All right. All right. So let's do some of the example now. Okay, before we move on to other examples. Okay, so here you need to write an expression as a logarithm. Okay, so here, let me just write down here. So write an expression as a logarithm. Okay, so let's do that. If you have this, okay, so that's your exponential one. So write this as a logarithm. So we remember this, how we write here, in here. Okay, so I write down here as well. So if you have here y equal to ax, so then logarithm a to the y, coy, sorry, equal to x. So you need to write this in this form. So what that would be? Okay, in here, let me just write down everything for you. In here, you see, this is your base when we write down here. Okay, that's your base. Okay, that's the exponent here is your logarithm. Okay, remember that. So once you know what is base, so base here is your here, a here, yeah, we already discussed, and that's your logarithm. Okay, so let's write down this expression. So we will say logarithm log 2, yeah, log 2. What is your y here? That is your y here, yeah. So logarithm 2 base 2 to the 32 is equal to 5. Okay, clear so far? So this is how, in other words, you would say what would you say actually? So you will say the logarithm of 32, yeah, 2. So this is how you say. Generally you say log no, base 2 32, but if you want to say the correct way, you can say the logarithm of 32 to base 2 is 5. Okay, so logarithm, so what we say, the logarithm of 32 to base 2 is 5. Okay, so I mean that is fine. If you want to say, most of the time we will use this expression. How do we will say that? But sometimes people say as well, like, okay, logarithm base 2 of 32, and that is equal to 5. But if you want to say logarithm of 32 first, so logarithm of 32 to base 2 is equal to 5. That's also correct. Okay. Okay. Let's do a few more examples on that one. So let's say if you have something like this. Okay. How would you write that expression? So this expression, you can say, okay, logarithm. Okay. So logarithm of what? 1000. Logarithm of 1000. If you go this way, base, what is the base here? That. So logarithm of 1000 to the base 10, yeah, okay, is equal to, your exponent here is 3. Okay, let's do one more. This time your, say, 5 to the power 4, that is your 6 to 5. Write this expression now. So with this, same again, logarithm of this time, it will be 6 to 5. Okay, 625. So you say logarithm, what is the base? That's your base. So you can put the base first, because sometimes you forget. So that's your base. Then you got 625. So logarithm of 6 to 5 to the base 5 is equal to, what is that? 4. Okay, so that's 4. So your what your exponent was here, that is your 4 here. Okay, so this is how you will write your logarithm, the expression. Okay, now let's move to the next bit here. Before we move on to and discuss few more examples, if you have, let's discuss some of the rules as well, because that is also important part. If you have a logarithm of a and you have 1 which is equal to 0, this is where a is greater than 0. Okay, then because, so we are down here, so just remember this please, because we're going to discuss that. A to the power 0 is equal to 1. Okay, if you have a logarithm, okay, a to the a equal to 1, where a is greater than 0, because a to the power 1 is equal to a. Okay, this is not something new. You have studied that in your GCSEs, and I have covered that in details. However, I will have the link as well, so that you can just still go and revise on that. Just remember this, because we will use this in our examples. Okay, so let's get some of the examples here. So it says here, find the value of, so let's go here, one of the example, which is okay, we sometimes say log 381. Okay, but if you want to use that terms here, logarithm of, okay, logarithm of 81, the base 3, whichever you want to say. So how would you write this one now? Okay, now here I will use the calculator as well later on, and explain to you as well how this actually work. So here you have base here 81, what that value would be. So what, in other words, I'm saying to you, with the base 3, and if you get base 3, what your argument of your x here, what that would be here. So okay, so that we can get 81. Remember that, where we already discussed that one. What would that would be? Okay, so because now it's in the logarithm, so log the base 381, what that would be. So let's say here, as you know, that 3 to the power 4 is equal to 81. Okay, this is because you know this thing, you can manually do this one. Okay, that's why you know, okay, this is what it is. So in that case we can say, okay, that 4 here. Okay, right. But as you know that that's cannot be the case all the time. I will explain to you that as well. So there's a table as well, logarithm table. You use logarithm table, and also in exam they allow you to use the calculator, so that you can get the details of that as well. So I show you now that how you actually calculate logarithm to the base 10 using your calculator. Okay, so this was just manually done. In exam, if they give you, then you can probably easily do some of these things. That shouldn't be any problem. And let's move on to here. You calculate logarithm. So you need to calculate the logarithm. Logarithms to the base 10. Yeah, so the 10, the base is here, and this is you doing it by using your calculator here. Okay, right. So find the value of x, which so you need to find the value. Find the value of x for which so let's say 10 to the power x equal to 500. Okay, so I got this one here. Okay, so now before we use your calculator and things, so let's talk a few things. So we know this is just a manual bit, but however we will use the calculator. So you know 10 to the power 2 is equal to 100. Okay, and 10 to the power 3 is equal to 1000. Okay, so you see we need to find 500. Okay, this is just explanation first before we use calculator. Then your x must be somewhere in between. Yeah, the x value here somewhere between that. Okay, somewhere between 2 and 3. Okay, because 2 is here, 3 here, so it should be something in between. You got it? So compare of this one. So your x value, so the value x here, that must be anything between 2 and 3. Okay, anything between 2 and 3. Got it? Right. So write down here what is the argument here about x. Okay, so we can say, okay, log. Okay, so we say log. We need to write that first before you even use calculator. Like log logarithm. Okay, the base 10 here. So logarithm of 500 to the base 10, yeah, equal to x. Okay, because we need to find x. Okay, now just use your, I hope you can see this one here. Okay, so you see here, this button here, that is your base 10 logarithm. However, this one is your base 10. Okay, you also have logarithm where you can change your base as well. Okay, so however here we will use this logarithm, which is by default here, and that is, you see here, that 10, it says 10 here. Okay, so that's the base 10. Okay, to the base 10. Okay, so this is what we will use. So the calculator will automatically presume that this is a base 10. Okay, so we click that on that one. See, it's been given to you. You need to insert the value. So it says logarithm, okay, of 500 to the base 10. So this is by default 10. So let's just put a value in there, 500. Yeah. And then you say, okay, equals, that give you 2.629. So here, okay, your x here, that is 2.69, and if you round up that one, 2.70. Okay, so logarithm or log or LG button on your calculator will be done, which gives you the logs to the base 10. So that is by default base 10. This is what is been given to you. Okay. Okay, so not necessarily you will get log 10 all the time. Okay, sometimes you get a different base as well. Okay, so for that you need to use you need to insert that as well. Okay, so this was just by default base 10. Okay, now let's say that you don't have base, so I'll just cover this as well. So for that you have button here on the top here, this bit here. Okay, this, when you click this one here, you see here, now the logarithm base you need to insert, because it could be anything. It could be 2, 3, 4, 5, not always 10. So that's why the box been given to you here that is asking you what's the base. So you can say, like here, you can say, okay, 10. Okay, so this time I actually insert that one. I key in the value 10, and then you can say, okay, what that next one would be. So from here you can go on the top. Yes, sorry, yeah, okay. So you can always go up, left, or here, and here you can say, okay, what was that one? 500. Yeah, so you can say 500. Yeah, okay. So I hope so now you know we use this button here, and let's see what we get here. See, again 2.69. So same thing. So either you can do here by default where it was 10, or whether you can just change the base here as well with this button as well. Okay, so these two buttons you can use. This by default 10, okay, base 10. Here any base, variable base, you can use this button. Okay, I hope it's clear. Okay, this is how we get some of the values like this. Okay, now if I discuss further, which is the law of logarithm, then this video will be really long. So what I do now this time, I say, okay, wrap it up here for our next video, where we will just recap on some of this example before move to the laws of logarithm. That would be a really important part, because this is where you will learn to solve the real logarithm problems. Okay, so for this time I would say let's wrap it up here, and do me a favor, if you're finding this video informative, please like and subscribe this video, and be sure to click that like button. Drop your comments if you have any questions, and I will try my best to reply. Okay, thank you.